I will come, okay?
You'll do what?
I will grab for me some food. I'm hungry.
Okay, no problem. Get some food. Okay, in the previous session, we said that covalent bond can be represented by 4 ways: electron dot diagram and structural formula and space filling model and electron model. And I've explained the hydrogen bond, or sorry, the covalent bond between two hydrogen atoms, and we call it single covalent bond. This is called single covalent bond. Let me type it here. And it's represented by a dash. We call it single covalent bond. Okay, covalent bond. Single covalent bond between hydrogen and another hydrogen atom. Let's take another example between hydrogen and chlorine. And this is hydrogen. I'm going to draw hydrogen. Let's draw it. This is nucleus of the first energy level, and this is chlorine, first energy level, second energy level, and third energy level. Okay. And the atom of the hydrogen, this is hydrogen. We have a nucleus inside it, one proton, only one proton. And in the first energy level, we have only one electron. Here, one electron. Okay. In chlorine atom, let's make it in red. We have a nucleus. Inside the nucleus, we have 17 proton. And 18, this is 17, and 18 neutron. 18 neutron. And in the first energy level of the chlorine, we have 1, 2 electrons. And the second, we have 8, 1, 2, 3, 4, 5, 6, 7, 8. And total chlorine is 17. So there is 10. So we have 7. 1, 2, and here is 3, 4, 5, 6, 7. So we have total 17 here. This is chlorine Cl17, C capital L small and 17. So this is non-metal and this is non-metal. Both of them want to reach the stable electron configuration. Hydrogen want to reach helium, which has only 2 electrons in the outermost shell. And chlorine want to reach the argon electron configuration, which has 18 electron. So this one needs to gain or share by 1, and this one needs to gain or share by 1. So chlorine will call on hydrogen. Can we share? Can we share with each other? Let's make hydrogen and blue and green. That's it. So they can share. The hydrogen can share 1 electron with chlorine, and then we will have a single covalent bond between H and Cl. Let's make them come close to each other. This hydrogen and this is electron, and that's the proton. Okay, and let's grab the chlorine. So they will share here, exactly here. 1 electron from here, and other electrons will come. 1 here, 1 here. Okay, both of them come here, and this come here. All of these 3 come here, and this one will come here. So these are 1, 2, 3, 4, 5, 6, 7 here, and this is the 8th one. Let me take the rest so you are not confused. This 1, 2, 3, 4, okay, 5, 6, and 7, and let me take this one inside here. 1. Let me take it. That's it. So they come here. This has only 2 electrons in the outermost shell. This is 2 electrons in the outermost shell, as you see here. And this one has 8. Like this. So right now, chlorine and hydrogen come closer to each other, and they share, each one shared by 1 electron. If each atom shared by 1 electron, we call it a single covalent bond, and we type it like this: H, then dash, Cl. So the type of atom here, the type of the bond here is also single covalent bond. Single covalent bond between hydrogen and the chlorine in hydrogen chloride. Hydrogen chloride. So let's see the double covalent bond. Right now, this is the single covalent. Let's see what is the double covalent. But before I go to the double covalent and triple covalent, I want to see something. Here, HH. We have here a nucleus of one hydrogen atom and the other nucleus. Each one has 1 proton. So each one of them is attracting the bond. Each one of them, this is positive, attracting the bonds in this direction. And this one attract in the opposite direction. So the bond here is called what? Non-polar covalent bond. Because the attraction is equal. We have the same nucleus in both sides. So we have similar attraction. So the attraction is similar in both cases. We call it like this one, like this covalent bond, we call it non-polar covalent bond. Non-polar. And we say that because we have the same attraction. Okay, guys? So this is non-polar because we have the same nucleus on both sides. But if we came to the case of chlorine, we have a nucleus that have 17 proton here, and we have another nucleus that have only 1 proton on the other side, in the case of hydrogen. So the attraction toward the chlorine is much greater than the attraction toward what? Toward the hydrogen. That's why chlorine has a negative charge partial. We call it negative charge or charge, partial negative charge. I'll type it again. Cl would have partial sigma charge. This sigma means partial negative. Again, if the chlorine take the whole electrons, he will take the electron of hydrogen with it. It will be completely negative. It will be Cl minus like this. But it take it most of the time, not totally, but most of the time toward chlorine atom. So it will be partial negative charge, and the hydrogen will be positive, partial positive charge. So in the covalent bond, if we have the 2 atoms, they are not the same atoms. We have 2 different nuclei. The attraction force will be greater toward some of one of these 2 nuclei, and it will have the atom that has greater protons or greater number of protons. It will have attraction force greater than attraction force for the electron bonds greater than the other atom. So the chlorine atom, which has greater number of protons, will have negative partial sigma charge or negative charge, negative partial charge, not total like this one, not like this one, but it's partial. At the same time, hydrogen will have positive partial charge. This means that the bonds here, the electron of the bond, will spend more time near the nucleus of chlorine, more the time they will spend near the nucleus of hydrogen. That's why hydrogen has a partial positive charge and the chlorine has a partial positive, partial negative charge. Because the atom, the electrons, will spend more time near the nucleus of chlorine because the attraction force of this nucleus is greater than the attraction force of this nucleus of hydrogen. So we call this one polar hydrogen atom. We call it polar covalent bond. Polar covalent bond. Okay, guys. So this is polar covalent bond because we have two different atoms. Let's see another one. And the polarity depends on the difference in attraction force. Here is the attraction force. The difference is not so large between hydrogen and example, be like hydrogen and oxygen. We'll take example like hydrogen and oxygen in the molecule of water.
Assalamu alaikum.
Alaikum salam. You just join us?
Yes, because the internet connection.
Okay. So this is also polar because the attraction force in the case of oxygen is greater than the attraction force in case of hydrogen. So oxygen will has a negative, partial negative charge. This is means partial. Partial means not total negative charge. And here is positive. And here is positive. This hydrogen. This is water molecule. So the water molecule is what? Is a polar compound. Again, the bond here between oxygen and hydrogen is polar. The covalent bond between hydrogen and the other side and oxygen is also polar. The atom, the molecule of oxygen total is polar compound. Remember, there is difference. Focus with me, bear with me. There is difference between polar compound and the polar bond. Here the bond is polar and here the bond is polar. Also, here the bond is polar. The polar bond will appear when you have two different atoms. Here the bond is not polar because we have similar atoms. Okay? Here the bond and the compound as total is polar because the compound has one part negative and one part is positive. In case of water, the whole compound is polar because we can separate it like this. We can make a line like this. And this will appear that the upper part of the water molecule, for example, in this case, in this direction, the upper part or one part of water molecule is negative charge or partial negative charge, and the other part has a partial positive charge. But if I give you another example, CO2, C, and here O, and in the other side, it's a double covalent, doesn't matter if it's double covalent. And here O. So let's see. This bond is covalent bond and polar because oxygen and carbon are two different atoms. So we will have a polar and oxygen has greater attraction force. The nucleus of oxygen has greater attraction force. So the oxygen has partial negative charge, and the other oxygen will have partial negative charge. And here the carbon will have positive charge. But the whole compound, again, the bond here is polar. The bond here is polar. The whole compound is non-polar. Carbon dioxide as a whole is non-polar. Because of what? Because the attraction force to the right cancel out the attraction force to the left. They are in opposite direction. We can say it like this because the linear shape of carbon dioxide, the whole compound is non-polar, despite the bond itself is polar. But in the case of the water molecule, because the bent shape, and this is subhanallah, creation of Allah, this is bent shape, make the compound of water molecule is the whole compound is polar. That's why the water molecule has high melting point and high boiling point. You see, carbon dioxide and water, they almost have the same atomic weight, mass number. But this one exists as water and boil at 100 Celsius. This one exists at room temperature as a gas. because the whole compound is linear and the whole compound is non-polar, and the polarity in the compound of water makes it has high boiling point and high melting point, and I will explain why the bent shape and the polarity of the compound of water make it have high boiling point and the high melting point. Let me show you. I will start with a hydrogen, a water molecule like this, O, and hydrogen, and another hydrogen. Okay, and I'll type here another oxygen atom, O, and hydrogen. As you notice, the bond between hydrogen and oxygen is single covalent bond. Okay, guys. The bond between hydrogen and oxygen is single covalent. And here we have the polar, the bond, single covalent bond between hydrogen and oxygen is polar because oxygen has a greater attraction force to the electrons of the covalent bond. So oxygen will has a negative charge, partial, and hydrogen will has positive, partial, and this hydrogen has a positive partial. And same applies for another or neighboring water molecule. Oxygen is negative, partial, and hydrogen is positive, partial charge, and this hydrogen is positive, partial charge. And from here arises something called hydrogen bond. Hydrogen bond arises between two different molecules. One with a negative charge and the other one, or one end of the molecule with partial negative charge and the other part is positive charge. Like this. This is dashed line represents the hydrogen bond between the negative charge, partial negative charge on oxygen atom on one water molecule, and the hydrogen positive, partial positive charge on another or neighboring water molecule. And same applies for another molecule. If I draw another molecule for you, it will be here, oxygen, and another hydrogen, and another hydrogen here. So this will be negative charge, and this will be positive charge, and this will be positive charge. Okay, and the attraction force arises between what? Arises between the negative charge on oxygen in one molecule and the hydrogen in other molecule. So this will be the hydrogen bond. This hydrogen bond between molecules requires a lot of energy when you want to evaporate water. And this makes the water liquid at room temperature, despite it has almost the same or even less, like the mass number of carbon dioxide. Carbon dioxide exists as vapor or a gas, but water exists as what? According to the hydrogen bond between molecules of water, water exists as liquid at room temperature, while carbon dioxide exists as a gas. That is the difference. That a water molecule has a bent shape, and this makes the whole compound is polar. While here, despite the bond between carbon and oxygen, the one bond or double covalent bond between the carbon atom and the oxygen atom is polar, the whole compound of carbon dioxide is non-polar because the attraction to the left cancel out the attraction to the right because the carbon dioxide has a linear shape. Subhanallah, Allah subhanahu wa ta'ala created water with a bent shape. This only bent shape makes it has the whole compound becomes polar, and this creates a hydrogen bond between the molecules of water, and this makes the water as liquid at room temperature and rises the boiling point, which is 100 Celsius for water. For carbon dioxide, it's by minus, I think, and I don't know what exactly it is. It's by minus, but for water, the boiling point for water is 100 Celsius. This very high boiling point according to the hydrogen bond between the molecules of water. And again, the hydrogen bond arises because the whole compound of water molecule is polar, and the whole molecule of water compound is polar because it has a bent shape, unlike the carbon dioxide, which has a linear shape. Only Allah subhanahu wa ta'ala created water with a bent shape, and all this was a result of that. It exists as liquid at room temperature, so we can drink it, and its boiling and the melting point is high, and a lot of other properties according to the existence of this covalent bond. So right now we have explained what is meaning by polarity in the bond. Polarity in the bond, when you have in the covalent bond, when you have two different atoms, one atom will have a stronger attraction force to the electrons of the covalent bond than the other nucleus. That's why one atom will have, the one atom with greater attraction force will have partial negative charge, while one with the less attraction force will have a positive partial charge. That creates what? A single covalent bond. If the covalent bond compound consists only of two atoms, surely two different atoms like this one, surely the whole compound will be polar, like this one. Hydrogen chloride is a polar compound. But if we come to this, if we have more than one atom, like had water and carbon dioxide, in the case of water, the whole compound is polar. But the whole compound in carbon dioxide is non-polar because it has a linear shape. The attraction force to the left cancel out the attraction force to the right. Despite we have the bond between carbon and oxygen is polar, the whole compound is non-polar. So we explained what is polarity and what are the results that come from polarity of water molecules. Water molecules arises between it hydrogen bond, and this hydrogen bond make water exist as liquid at room temperature, despite carbon dioxide, which has the same mass number, is gas at room temperature. Water, according to the hydrogen bond, exists as liquid at room temperature, and it has high melting point and high boiling point. Any question about polarity, guys? طيب. After explaining polarity, I will explain to you what's the meaning of double covalent and triple covalent bond. I will start with oxygen atom. I will start with oxygen atom here. This is the first level in one oxygen atom, and this is the second energy level in another oxygen atom. Okay. Let me just put it like this. Control C. Take another one here. So, this is one oxygen atom. This is oxygen atom, O8, 16. And this is another oxygen atom, O8, 16. In the middle here, you will have the nucleus. I'll just do the nucleus like this. Inside the nucleus, you will find the protons and the neutrons, as you know. And let's draw the electron configuration. First level has 2 electrons. Second, 1, 2. We have 6 left out of 8, so 6 in the second level. 1, 2, and 3, 4, 5, and 6. So we have 6 here. So it needs to be 8. It needs to reach the stable electron configuration, which means in the second energy level saturated by 8. So this one needs to gain, oxygen needs to gain or share by 2 electrons, so it will fill its outermost energy level. Let's draw the other oxygen atom. 1, 2, here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 and 2, 8. We have 8 electrons. So each one of these oxygen atoms needs to gain 2 electrons. What would happen? Those 2 atoms will come closer to each other, and they will share 4 electrons like this. This one completely will come to this one here, and this one will come closer here. So they will overlap, and they will share electrons. This one will share by 2. Yes. And this one will share by 2. Okay, and let's continue with this side here. And this is the nucleus here. I will erase it and it started from the beginning. This one, erase it all. So they come closer to each other like this. Make this much smaller. Make this a little bit bigger. And we have here the nucleus. This is a nucleus here, and this is a nucleus here. And the first energy level still has, here 2 electrons, and second one has 6. 1, 2, 3, 4, 5, 6. And for the other one, we have 1, 2 from the other one, and 1, 2, 3, 4, 5, 6, and here 1, 2. So oxygen atoms overlap, they overlap with each other, and they combine with each other or share by 2 electrons. So each one of them shared by 2 electrons, as you see. If each atom shared by 2 electrons, we call it what? Double covalent bond. We do it like this. We write it like this. O, double bond, O. So the type of the bond between two in the oxygen molecule, which is written O2, is double covalent. But in the hydrogen, which was written as H2, remember, hydrogen is written as H2. The type of bond in hydrogen molecule is single covalent bond. The type of atom, the type of bond, the type of covalent bond in oxygen molecule is double covalent bond. If we make another example, for triple covalent, I want to draw this. I will just draw directly the overlapping of the 2 atoms is nitrogen. Nitrogen has 5 electrons in the outermost energy level. This is the first energy level, and this is the second energy level. And it has, nitrogen totally has 7 nitrogen. 7 protons. So in the first energy level, we will have 1, 2. In the second energy level, we have 5. 1, 2, 3, 4, 5. Needs to gain 3 or share with 3. If we draw another one beside it, it will be the same, another nitrogen atom. Okay. And so the second hydrogen atom has, in the first energy level, 2, 1, 2. And in the second energy level, they have 1, 2, 3, 4, and 5. So this one and this one, they are the same. I'll make this a little bit bigger. I will just make this the same so you will not get confused. Okay. So after this, they will overlap. This one will overlap with this one and become like this, and this hydrogen atom, the 3, each one shared by what? By 3, and this one will come here, and this one will come here, and the first energy level is not affected. So on all types of, this is nitrogen molecule, a nitrogen atom, and this nitrogen atom, this is molecule N2. The type of bond in nitrogen molecule is, we have only two nitrogen atom, is triple covalent bond. If we draw it, it will be like this, N triple bond N. So right now we have explained the double covalent, triple covalent, and polarity, polar and non-polar in bonds, and polar and non-polar in compounds. Here we are sharing by 3. If you notice that in all type of covalent bond, sharing between electrons occurs only in the outermost electrons. We are not sharing with the inner electrons. The sharing happens only with the outermost or valence electrons, and it will share by one. If the atom needs one in the last shell, it will share by one. Like what? Like here, hydrogen. Like hydrogen here. Hydrogen here only share by one because it needs one to fill its outermost shell. In the case also here, chlorine needs to share by one and hydrogen needs to share by one. So we have single covalent. If we come here, oxygen needs 2 electrons in the outermost to have a stable configuration, which is 8 in the outermost shell. So it will share by 2. So each oxygen atom of this will share by 2. So we'll have double covalent. So you will have single covalent of each atom shared by 1. You will have double covalent of each atom shared by 2. You will have triple covalent if each atom shared by 3. So we have double covalent, single covalent, and single covalent, double covalent, and triple covalent bond. And we talk about polarity. And we said that in hydrogen atom, hydrogen molecule, like this one, that's hydrogen molecule. In hydrogen molecule, there is a bond, the covalent bond is non-polar because they have the same attraction. If we come here, the hydrogen chloride compound, chlorine has greater attraction force to the electron of the covalent bond than hydrogen. So electron will have a partial negative charge and hydrogen will have a partial positive charge. And this bond is called a polar covalent bond. The whole compound, because it consists of only 2 atoms, is polar compound. Here we have a polar compound. We have polarity here and we have polarity here in the bond. But the whole compound of water is polar. The whole compound of carbon dioxide is non-polar. That's because the carbon dioxide has a linear shape, so the polarity to the right or the attraction to the right cancel out the attraction to the left. So the whole compound of carbon dioxide is non-polar, while the compound of water is the whole compound of water is polar because the water has a pin shape. And this pin shape creates the polarity of water molecule, makes a hydrogen bond between the positive part of water molecule and the negative part of another water molecule. This hydrogen bond increases the boiling point and melting point of water, and it makes water exist as liquid at room temperature. Okay, guys? Okay, right now I'm going to share with you a quiz about covalent bond. 1 minute to share with you a covalent bond quiz. Okay, master postgrade, 69th grade. Just 1 minute, no matter the second of it. So in this quiz, you will find some ionic and some covalent bonds that we have studied. It's 22 questions. Try to solve it quickly. We have only 10 minutes. I will share with you the screen. So this is the link, and this is the pen. You can use the pen directly. Join the quiz, guys. So join the quiz using this link, please. Quickly, guys, join the quiz. Only 5 entered. Come on, guys, enter the quiz. I've called the names for absence right now while you are starting the quiz. I'll start the quiz.
No, wait, mister. It is loading.
I'll call your names. Take the absence during having the quiz. Abbas, but quickly, guys. Abbas,
Yes.
Abdul Majid,
Here, mister.
Abdul Hadi.
Here, Mister, here.
Okay. Abdullah Husseini.
Yes.
Okay. Abdullah Muhammad Al Abdul Latif. Abdullah Muhammad Abdul Latif.
He wrote here.
Huh?
He wrote here in the
Okay. Abdullah Abdul Aziz Dahlan. Abdullah Dahlan.
here, mister.
Abdullah Al Mubarak. Abdullah Al Mubarak. Abdul Rahim Adil. Abdul Rahim Adil. Adham. Adham. If somebody type in the chat, guys, tell me. If somebody type in the chat, tell me. Adham Abdul Rahim Adil all the time. And Adham Abdul Rahim Adil. Where is Adham?
Mister,
Yes, who's talking?
Muammal, can you send the link again?
You just join us, Muammal?
No,
Okay,
mister,
Mom.
but the connection is bad.
I sent it again, Muammal. Okay. So Adham وعبد الرحيم didn't answer me. Ahmed متعب القناص.
Yes, I'm
Ahmed.
here.
Okay.
Yes, I'm here.
علي أحمد. Okay. علي يوسف الهلال. علي يوسف الهلال. فيصل. فيصل. حسن عبد المجيد منصور.
Here.
إبراهيم عادل.
Mister, I think Faisal is here, but I think his mic is broken. I think.
I am here, Mr. Ibrahim is here.
Okay. ده مين إبراهيم عادل؟
I hear.
Okay. Faisal have to type in the chat. If you don't have a mic, Faisal type in the chat. إبراهيم أنور.
I'm here.
إبراهيم محمد عبد الله الربيعة. معاذ.
Yes, I'm here.
مؤمل. ليت. محمد أيمن الملحم. محمد أيمن.
Yes, mister.
Yes, مؤمل you come late صح؟ محمد عبد الباقي is here صح؟
Yes, Mr. Always.
مؤمل you come late to the session مؤمل؟ طيب محمد أحمد
No, mister,
رمضان.
I was here from the beginning, but the internet connection is very bad.
Mister, I think Muhammad
I'm
Ayman
here,
is
Mister.
here too,
Muhammad
but I
Ramadan is
think
here.
he's in the bathroom or something like that. I think.
ومين تتكلم عليه؟ Who you are talking about؟
عبد الهادي.
عبد الهادي يتكلم الحين هو. طيب.
No, Mister, I think Muhammad Ayman is in the bathroom. That's why.
محمد أيمن. محمد أيمن sent to the bathroom. When he come back, just tell me. مرتضى.
Here, Mr.
محمد فضل. ده كل name محمد.
Yes, I'm here, Mister.
نفجان. نفجان. أسامة. أسامة. سعد محمد اليامي.
I'm here, Mister. I'm here.
Mister, noble gases can form bonds, right? If they have high energy levels to bond them.
They don't react at all.
At all? Not even with a strong...
with special conditions they can react. Very special conditions. سعد الحسيني.
So it is sometimes or false?
What the question says again?
It says noble gases, can they react? True, false, or sometimes with other materials?
Cannot react. UTAP cannot react. He didn't mention any conditions, so cannot react.
Okay, Mister, another question. CCl4, it is carbon something chloride. It says
Tetrachloride.
Why is it tetra? It should be quadra.
No, tetra. The force means tetrachloride. I think we have finished the lesson. You can read it from this one. We have covered most of the lesson, so no need to come back to it. So we have finished all of this, attraction force and covalent and all of this. Okay, guys, right now I'm going to end the session.
Thank you, Mr. See you tomorrow.
Thank you, guys. See you tomorrow. But I will leave the quiz for you. If you didn't finish